What law governs the energy transformations of motion on an inclined plane? This is the question students explore in Investigation 10A, Inclined Plane and the Conservation of Energy. This investigation is broken into two parts. In part one, students use a smart cart to explore how the gravitational potential energy and kinetic energy of a cart changes as it rolls down an inclined plane. In part two, students use a simulation to explore a cart on a ramp that has a fixed final speed at the bottom of the ramp. They explore how changing one variable like incline angle affects the other variables in order to keep the final speed of the cart to 30 miles per hour at the bottom of the ramp. Before beginning part one, students should sketch prediction graphs of position, velocity, potential energy, and kinetic energy versus time for a cart rolling down an inclined plane in their handouts. Have students sketch the position and velocity versus time together in one graph, and potential energy and kinetic energy versus time together in the other graph. For part one, attach the track feet, end stop, and angle indicator to the track, and then mount the track to the tripod using the track bracket such that the incline angle is exactly 15 degrees. Set the cart at the bottom of the track with the cart's force sensor pointing up the track. Open the 10A experiment file and connect the cart using Bluetooth. Start recording data with the cart resting at the bottom of the track, then roll the cart up to the top of the track, hold it in place, and release it. Catch the cart at the bottom of the track and stop recording data. On page 1 of the experiment file, rescale the graph to show only the data while the cart was rolling down the track. Sketch a copy of the position and velocity curves in the first blank graph in the handout. Do the same on page 2 with the kinetic and potential energy versus time graph. Sketch the graph in the handout and then use the multi-coordinates tool to explore the potential energy and kinetic energy values of the cart as it rolled down the track. Students should note that the sum of the potential and kinetic energy is constant, or nearly constant, throughout the cart's descent, implying that the energy was conserved as it rolled down the track. Part 2 of the investigation uses the interactive simulation found on the 10A investigation page in the ebook. Students set the final speed at the bottom of the ramp to exactly 30 miles per hour, or 13.4 meters per second. Then students adjust any of the variables and observe how the other variables change to keep the final speed at the bottom of the ramp equal to 13.4 meters per second. Notice that the starting height of the cart remains constant regardless of the incline angle. This is because the cart's gravitational potential energy is not dependent on incline angle, but is dependent on the cart's starting height. Students can also observe graphs of the cart's position, speed, potential energy, and kinetic energy by checking the boxes next to the graph.